going to continue from here, and then we're going to take it and we're going to try and push as furthest as possible. So here's exponents, which is part of obviously the things that you need to know, and so on, right? So we work piece by piece, and let's see in this hour how much we can do. Because as I told you, I'm also writing tomorrow, so
Yeah, I know, I understand. Yeah.
yeah. So let's get started, and basically we're gonna get started here, right? And yeah, I know with physics, I would usually want to do the ones that count the most, but with maths, everything counts. So it's best to just know as much as possible, because really,
Yeah.
you find that especially with the first question one, question two, question three, it's usually a lot of marks. It's usually quite a lot of marks. If you can ace those things, then you can actually pass quite well, right? So the first one that we're going to start off is this one, 1.2, just continuing from where we left off from the video. So 1.2 basically says solve for x and y simultaneously, right? And we have y plus x is equals to 2, and x squared plus 3xy plus 8 is equals to 0, correct? So it's a simultaneous equation. The best method that you could always use in this case is definitely by using substitution. Actually, always use substitution. Don't try elimination, because elimination has certain conditions to it, right? So you'd have x y is equal to x, and apologies if I'm going too fast. Please tell me if I'm going too fast,
Yeah.
and then and stuff like that. But as I said, I just want to try and get through as much as possible in this hour that we have, right? So
Yeah.
it's 3xy. I think it said plus 8, right? Is it plus 8? Yes, plus 8 is equals to 0. So generally, the idea with simultaneous equations is that you rather choose the equation that would best be easily manipulated. In this case, here you have a quadratic, and it's a bit complicated. So the best thing you could do is to rather use y plus x, and
Like for in that you can either let it be x is equal to 2 minus
yes,
y, or y is equal to 2
yes.
minus x. Does it really matter?
No, it doesn't matter. So whichever way you put it, whether you say it's x
Okay.
is equals to 2 minus y, or y is equals to 2 minus x, it wouldn't matter, because at the end of the day, you're still going to just substitute that value into,
Good. Yeah.
yeah.
I don't want
So
to make sure that.
yeah. So in this case, then let's rather choose maybe what? Let's choose y. Okay, I'll choose y. So I'll say y is equals to 2 minus x. And then the first thing is that you need to name it, right? So that they know what you're substituting what into, right? So we say this is equation 1, and then we have equation 2. So you just write out the equation 2 as well. So it's 3xy plus 8, that's equals to 0. And then we put the dots, and that's equation 2. And so then you'd say I would substitute 1, right? Equation 1 into, right? Equation 2, right? And
Yeah.
when we substitute that into equation 2, that would mean that wherever y is, then we would put in 2 minus x. So we only have one place where y is, so we'd say it's x squared plus 3x, and then there's the y, so then we put in 2 minus x, so it's 2 minus x, and it's plus 8, right? And then from there, it's just simplifying, right? And then solving for x, right? So now we have 3x times 2, which 3x times 2 is supposed to give us 6x, right? So then it would be 6x. And then it's 3x times minus x. But then that would be positive 3x times negative x, right? That would be negative 3x squared. Correct.
3x squared.
And then it's plus 8, it's equals to 0, correct? And then from there, then we substitute, we just like terms, right? And then it will be minus 2x squared plus 6 x, sorry, and plus 8, right, is equals to 0. Now, in that case, now, since we have that, I mean, you could possibly, if you just want to get the answer, you could just use the quadratic equation, or you could first divide by -2. So I'm going to just divide by -2, but you could have also just used the quadratic equation as is at this point, right? Because it is a quadratic equation, right? Quadratic formula, right? So you could have used the quadratic formula immediately, or you could just simplify it further. So if we had to simplify it further, I'll divide by -2 because 2 does go into 6 and 8, right? So then that would be x squared, right? Minus 3x minus 4, right? Is equals to 0. And you notice that the signs have changed because I divided by -2 to get that we have x squared on its own. But now, if we have that, again, you could use your quadratic formula immediately from here, or you can factorize. So if you feel unsure about your factors, rather use the quadratic formula immediately. But in this case, you could just use factorization, where with factorization, you could see that here it would be actually -4, right? And +1, because -4 and +1 would give you -4. And then when we actually multiply -4 with x, will give us -4x. But then with 1 and x, that's positive x. And when you add -4x and plus x, that will give you -3x, right? Just as a reminder. And then from there, then you can just say, okay, x is equals to 4, -4 is equals to 0, or x could be +1 is equals to 0, right? And then the answer is x, that is -1 and 4, right? And remember why we say or. You need to say or because the whole point of this is that it's saying that if we have a value for x minus 4, and that value is 4, if we put it into the equation here, it will be 4 minus 4, which is 0. And then if it multiplies with this one, it would give us 0. And the same thing as well. So it's either one of the two would, if we substitute it, it would give us 0, or both of them at the same time, it would give us 0. Okay. And then, so from there, since it's simultaneous, the only thing now we need to find is what? It's what our y is, right? So then you could just take x for the 4. And remember, they are actually paired together, right? They're actually paired together. So this 4, you put it in 2 minus 4, right? And 2 minus 4 would just give us -2, correct? And then as well with y on this case, with x, that is -1. Then when we put -1 in that case, then it's 2 minus -1. But then 2 minus -1 would be 2 plus 1. So then
Plus
2
3.
plus, yeah, so it's just 3. Okay. And that's your solution in that case. And it's 4 minus 2 and -1 and 3. And just to, as a reminder about this simultaneous equation, especially when you have two equations, if you could think of this, you could also think of this as two functions, right? This could be a straight line function, and that could be a parabolic function. And then the answers that we get is telling us where these two functions are actually intercepting each other, okay? So simultaneous equations are also useful in that case. And then 1.3 says the roots of the equation f of x is equals to 0, right? X equals to 4 plus minus the square root 16 minus 4m, all into minus m plus 5, all divided by 2m, right? So they actually gave us x, the roots, in terms of the quadratic formula, right? And then they say determine the values of m for which, right? For which the roots will be non-real. Okay. Let me just switch off this thing. I think someone is texting me here. Okay. Did you hear it? That is it.
No.
I mean, did you hear the yeah?
No, I didn't.
Oh, you didn't. Okay. Okay, then that's awesome. Okay. Okay, so it's 1.3, and they are saying that we need to determine the values of m, right, for which the roots will be non-real, right? But when is something non-real? Do you remember when they talk about a discriminant? When should it be non-real? So when they talk about non-real, right? It's more like in the calculator, it would not give you an answer. It would say math error.
yeah.
It would give you a math error. But when is that possible? When you have this equation or the quadratic formula like that? Where does that come from? What causes that?
What causes what?
So what causes this problem where we have non-real roots? Non-real, meaning when we put in a
A
calculator,
negative
yeah,
when it's a negative square root.
yes, when inside the square root, there's a negative number, meaning this 16 minus 4m minus m plus 5, if it's less than 0, meaning it's a negative number, right, then it won't be real, correct? That's what we are saying, right?
Yeah.
So therefore, what we just need to do is take the 16, right, and it is minus 4m, right, minus m plus 5. That is supposed to be less than 0 because we're looking for non-real roots. So from there, the only thing we need to do is what? Is just to simplify and actually solve the inequality, right? So now, when we simplify this inequality, it's 16, right? Minus, so it's minus 4m times minus m. If it's minus 4m times minus m, then it's positive 4m squared, correct? And it's minus 4m times 5. So then it is minus 20m, right? So then we have minus 20m. That is all supposed to be less than 0, right? And so if it's supposed to be less than 0, then the only thing we need to do is find the critical points, because remember, this is still an inequality. So you try and solve it like a normal quadratic inequality. So this is m like that plus 16. But before we do that, could we simplify it even further to make it easier for us to see the roots? Yes, right? By dividing by 4.
Divide by 4.
Yeah, so we divide by 4 everywhere, and so we get that it's m squared minus 5m, right? Plus 4, right? That is less than 0, right? And then from there, the factors for this would be in between what? It could be in between. So I'm going to say critical values. Okay, so actually, since it's a quadratic, you could have also just gone to this point where you said it's m squared, I mean the factors.
Yeah, I was gonna ask about that now.
Yeah, you could have also done it like this, or you could have just gone to the critical values immediately. So I'd say, okay, I have the critical values, right? Because remember, unlike a normal unlike a normal equation where you found the factors, with inequalities, you're not actually solving for a single value, you're solving for an interval of values, a set of values. So that's why we have critical points, where those critical points from there and all the other values going to the right of it and to the left of it, we're trying to figure out which one would give us negative value, right? Would give us a negative value. Which other values, when we put it into the equation, would give us a negative value. So then we say, okay, critical values, right? And the critical values in this case would be m, that is equals to 4, right? And m, that's equals to 1. And then, okay, there's a number of ways again. I also explained it in the other video when we did the inequality question. There's a number of ways that you could have drawn out your values, right? So we place 4 on the right-hand side because obviously it's the bigger number, and 1 on the left-hand side because it's a smaller number. And then this is the number line. You can think of it, this number line, as the normal real number line, where it's from negative infinity on this side to positive infinity on that side, right? So now,
how did you know how to get your critical values without doing that?
Sorry, without doing.
If you didn't have to do that m, where you have the 2 brackets.
Yeah. Okay, so those critical values, remember, they're actually still the same as if you are kind of solving for an inequality, right? But now the difference is that with inequality, I mean, for a normal equation, but the difference is that from a normal equation and an inequality, and this is an inequality because we have less than zero,
Mm.
right? These factors where it's m minus 4 and m minus
This
1,
inequality is only less than 0. So what if it was
it
more?
can,
What if
yeah,
that?
it
What if
could
that
have
sign
said
was
it's
more than
more.
0?
So for instance, if the question was saying it's more than 0, then you still would have done the same. But now, where is it more than 0? This is where the number line comes into play, where it will tell us where it would be positive or negative values. So let me show
Oh,
you.
so
Yeah.
so the less than 0 just two sides on the other number lines in a look.
Sorry, repeat that.
Like it was less than 0 or more than 0. Does that just show whether how on the number lines in a look?
So it doesn't tell us about how the number line, yes, it would tell us how the number line would look in a sense that between 1 and 0, would it be positive values when we put it in here? So let me first do it and then maybe let me try and re-answer your question, okay? So in this case, when we continue in doing it, we have m minus 4 and m minus 1. But the critical values is 4 and 1. So there's the 1 there, there's the 4 there. Now, generally, we would say this is an open dot, right? An open dot. Why? Because this is not less than or equal to, it's just less than, meaning it's not including 1 and it's not including 4. It's including anything greater than 4 or anything less than 4, but not 1
So if there's
itself.
more than 0, would it be the close circle?
So if it's just more, if it said it's greater than 0 like this, and it's just
Mm.
greater and not greater or equals to, it's still open. So if it's just greater, right, then it is a open circle that you're gonna put into your number line. But if it is greater or equals to, and this also applies for this one as well, if it was even less than or equals to,
Then
then
it's closed.
it's a closed dot, and it's a closed dot. But if it is
Open.
greater than 0, this would be an open dot. And if it's less
Okay,
than
yeah, that
0,
makes
it's
sense.
still an open dot. Okay.
And in this case, you can't have both, no?
Yeah, you can't have both, right? You
Okay, I
can't
just wanted to
have
make
both.
sure. Yeah.
And what tells you when you should put in open and closed dots? It's obviously the question itself. In this case, the whole question was that it's supposed to be non-real. But if it's non-real, it means that it's anything less than 0. It's not something that's equal to 0, because remember, what happens with the discriminant when it's equals to 0? It makes the roots equals to each other, right? Meaning there's actually a solution that will come out. But now they said non-real, so we don't want a solution to come out. We want a math error to kind of appear in your calculation, right? So it has to be
Yeah.
less than 0. Anything that's less than 0, meaning any number that is negative, right? So from here, what do we do to actually figure out in between 1 and 4? Will it give us negative values for the discriminant, or positive values or positive values? So what we do is between 1 and 4, then we choose any possible number between 1 and 4. Any number that's between 1 and 4, and not 1 and not 4. Not 1 and not 4, right? Because they are not included. That's why we have an open dot, meaning we are not including 1 and 4. But we will look at any number bigger than 1 or smaller than 4. Okay, so for this interval here from 1 to 4, any number that's between 1 and 4, the easiest number that I can think of that is in between 1 and 4 is actually 0. So if we put 0, so what you take the 0, you take 0 and you put it into what you got here, right? This point here, right? Where it's m minus 4 and m.
How's 0 in between 1 and 4?
Oh, sorry. Not 0. Sorry. 2. Sorry. Sorry. Good one. Yeah. Between 1 and 4, it's 2. Sorry. Let's take 2. Sorry. My bad. I don't know what I was thinking of. Okay. Anyway, so it's 2. Let's take 2. So if it's 2 minus 4, that would give us minus 2, right? And then it's 2 minus 1, that would give us 1. but then it's -2 and 1. If we multiply -2 and 1, that will give us what type of number? It would give us a negative number, because it's a negative number times a positive number. That will give us negative, right? So it's a negative value. So what we should expect is that in between 1 to 4, it should be negative values, right? Let me use a green color. Okay. Okay. And then for 4 to 0, from 4 to infinity, sorry. So from 4 to infinity, I think it's because I'm going a bit fast. I'm trying to be too fast. Okay. So from 4 to infinity, right? What number can we put in? Let's try out 5. So if we put 5, it will be 5 minus 4. 5 minus 4 would give us 1. And 5 minus 1 would give us 4. But then 4 times 1, that would give us just 4. And 4, that 4 is a positive number. So this side, we would expect that any number from 4 to infinity should give us a positive value. And then as well with 1 to infinity, so maybe let's take 0 now. So when we take 0 now, then it's 0 minus 4, that gives us -4. 0 minus 1 would give us -1. But -4 times -1 would give us a positive number, because a negative times a negative gives us a positive. So any number that is less than 1 to infinity would give us a positive value for this expression, right? So from there, this tells us what we need. Now the question itself, now we go back to the question itself. The question is about less than 0 numbers, right? It says less than 0. So where do we find any number that is less than 0? It's between 1 and 4, but it's not included. Hence, we'd say it is the m that is less than 4, but also m is bigger than 1. And we don't say it's less than or equals to 1, right? Because it's not included, okay? So it's just 1, m, where it is bigger than 1, and m, when it is less than 4, that we would find that would have non-real values. Non-real roots, right? So that's when we would actually get non-real roots. Okay. Does that make sense?
Yep.
Okay. Okay. Anything you find with this one?
Yeah.
Okay. Awesome. Okay. And then 1.4. So 1.4. I think 1.4 is a bit more challenging. And usually in question 1, the last question in question 1 is usually the most challenging ones that you find. So with question 1, it says, show that the maximum value of the square root of -x squared plus 4x plus 12 is equals to 4. Now they say the maximum value, right? They want you to show that for square root -x squared plus 4x plus 12 is 4. So the maximum value for this expression would be 4. But inside the equation itself, what do we have? We have -x squared plus 4x plus 12, which is what? It's a quadratic expression, right? But what can we, yeah.
No, fine, carry on.
So what could we expect from this type of expression is that if you think of it as a function, if you think of -x squared plus 4x plus 12 as a function, what type of function would that result? It would result into a function that would probably be looking down like that, correct? It would probably be looking down like that. But if it's looking down like that, right, that function of -x squared, I think it said plus 4x plus 12. I know that the shift is probably not correct, but it's just to explain the whole idea, right? So it's -x squared plus 4x plus 12. So we would expect that probably it's something that's looking down because a is looking, it's a negative number.
Yeah.
So if it's a negative number, according to functions, it tells us that a would give us either a smiley face or a frown, right? So in this case, it's a frown, it's looking down. So if it's looking down as a parabolic function, that would mean that somewhere along the line, that y, this expression would give us a maximum value. And where would this maximum value be at? It's
Top.
the turning point. Yes, the top, right? The very top, which would be the turning point. So we expect that the highest value that this expression could ever give us would be at the turning point. But what do we know about functions and quadratic functions as turning points? So we would say negative x squared, right, plus 4x, right, plus 12, right? We could do it two ways. Let me fully explain this. So I'm going to write it fully. So I'd say outlet f of x be equals to, so to show that I'm thinking of it as a function, right? As a function of numbers. So it's 4x plus 12, right? I'm thinking of it as a function. But now we're looking for the turning point, right? We're looking for the turning point because the turning point y is the maximum value of this expression, correct? So the maximum value of this expression is going to be at the turning point of this parabolic function. Now, there are two ways that you could get the maximum value, right? You could either use x is equals to minus b all over 2a, right? Right? Which would give us what? The x value. So this would be the x value of the turning point for a parabola, right? This would be the x value for the turning point of a parabola, right? Or what could we have done? We could have completed the square, right? We could have completed the square, right? So which one do you think you want to try? Maybe let's try the completing the square because this one is very straightforward. You just take.
I was going to say, can we do that one?
Yeah, completing the square, right? So let's try and complete the square. So if we have to complete the square, okay, we have f of x is equals to minus x squared plus 4x plus 12. And so in this case, then if we want to complete the square, remember completing the square requires that our a here has to be just 1, not negative. It can't be 2, can't be 3 or anything like that. It just needs to be a positive 1 coefficient, right? But how can we do that? Then we have to take out negative 1, right? So if we take out negative 1, and then we have x squared, right? Positive, and then it's minus 4x, and then it's minus 12, right? And then from there, when we get to this point, then completing a square, then we take the b minus 4x, right? And we take this minus 4, we divide it by 2, right? We divide it by 2, so it's minus 4 divided by 2 will give us negative 2. But then negative 2, the whole negative 2, we would square to the we would raise it to the power 2, and that will give us 4, right? So then from there, that 4 that we get, we would say it is minus 4x plus 4 minus 4, right? And why did we say plus 4 minus 4? So that we don't actually change the expression, right? So we need to add plus and a minus 4 to kind of cancel each other out. But the whole point is that we're trying to manipulate the equation. So we manipulate it in such a way that for the first bracket, for the first 3 terms, which is these ones here, which is x squared minus 4x plus 4, we get actually an expression that is squared, meaning that when we expand it, we can get back to this point, but it's squared. So it's a square expression. So we will get that it is x minus 2 to the power 2, right? So that's completing of a square. When we talk about completing of a square, we're actually trying to create an expression where it says x minus something squared. And this x minus something squared, when we try to expand this, this would give us this part in the bracket, right? And then the other part, which is minus 4 minus 12, that would be just minus 16, right? So that would be minus 16. I actually wanted to use black, not green. So it's minus 16, right? But then it's still all being multiplied by negative outside. So then when we multiply inside, then we get that it's minus x minus 2 all to the power 2 plus 16. But now we've completed the square. So if, okay, apologies on that. Are you still there?
Can you hear me?
Yeah,
Yeah,
sorry.
can you hear me?
Yeah, sorry on that. It does this sometimes, but let's see if it does it again. I'm just gonna use my data, okay?
No worries.
Okay, and then please tell me if it starts doing it as early as
Okay,
possible, so then I'm not talking and you're missing out, right?
I was about to say, and then it just went off.
Oh, okay. So let me go back to what I was saying. So remember, when we talk about completing a square, we're basically trying to create an expression which is x minus 2 to the power 2, which would give us that. And that's why we plus 4 and minus 4. But the first one where we plus it, we would just put it together. And then we factorize x squared minus 4 plus 4. But when we factorize this, this would be just x minus 2, right? To the power 2, because it would have been x minus 2 times x minus 2. Okay. And then we'll take the minus 4 and add it with the other number outside, which is minus 12, which is going to give us negative 16. But then outside, remember, we had minus 1. So there's the minus. Then we multiply the minus inside, we'll get it's minus x minus 2 to the power 2 plus 16. Okay. And so this tells us that what? It tells us that the turning point is at what? It's at 2, right? The turning point, the coordinates, it's x map, so the coordinates of x maps y for the turning point, right, would be 2 maps 16, right? So when x is equals to 2, then minus x squared plus 4x plus 12 would give us what? Would give us 16, right? When x is equals to 2, correct? Mm. And basically, if you look at this, remember the question said the square root of 4. So when we square root this x squared minus x squared, sorry, plus 4x plus 12, right? Which is supposed to be equal to 16, which is 16, would be, give us what? 4. And that's exactly what we were looking for, exactly, which is 4, right? So we've just shown, so when x is equal to 2, then this expression is 16, therefore the maximum, when the maximum is given by, so the maximum, I just used a lot of so the maximum, will be given when x is equals to 2. And basically we've just answered the question right there. Okay. And then the other one, it's the same thing, right? Which here it was actually quite quicker, where you would have gotten 2 quite easily. And then after that, you would have just taken that value of 2, and then you would have put it into the equation, and then you would have found that it is 16, and you would have proven it by that that would be the maximum value there. Okay, awesome, right? Okay, are you okay? No questions?
Yep.
Okay, so now sorry,
you can carry on.
Okay, so now let's get into exponents, right? Let's try and do these exponents. Oh, I remember, was it with you? There's that other exponent one, I think it was in July, that was so long that it confused us. Remember that one? But anyway, let's see this one. Hopefully this one won't embarrass me like the last one. But anyway, let's try this out. So it's 2.1. So they say without using a calculator. And so we have 2.1. So 2.1, let me write 2.1. So there is 2x to the minus 3 times, it's not times, it's, okay. So it is minus 3 times 2x plus 1, all divided by 2x minus 2. Okay. So this is the expression that they want us to simplify without using a calculator, right? Okay, so let's first simplify it and see what we get. Let's use our exponential rules. So now when you see x, 2 to the power x minus 3, this means that it was just 2x multiplied by 2 minus 3, because remember, the same bases, when we have two bases that are the same and they're multiplying each other, then it would add the exponents. Sorry?
Yeah.
So we'd add the exponents. When the bases are the same, we'd add the exponents. So this would have been x plus minus 3. But then when we simplify that, then it's just x minus 3. And then we do the same thing here as well. So then it's just 2x and 2 to the power 1, all divided by 2x times 2 to the negative 2, right? We separated them, okay? And then the whole point here now is because since you have an expression or two terms, and what do I mean by two terms? I mean that they're being separated by a negative. Whenever you see terms, it's usually separated by a negative or a positive, right? So these two terms, you have the first term and the second term. In the first term, you have 2 to the power x, and in the second term, you have 2 to the power x as well, right? There's 2 to the power x as well. So what that means, we can use common factor factorization, right? So when we factorize that, then we'd say it's 2 to the power x outside of it, and then we'd be left with 2 to the power negative 3 minus 3 times 2, right? And 2 to the power 1 is just 2, right? Because we don't usually write the 1, right? So you know y is just 2. And then we have at the bottom 2 to the power x times 2 of negative 2, right? And then in this case, at the top now, we have 2 to the power x multiplying the entire thing that is left off in the brackets, which is 2 to the power minus 3 times 2, right? Because of that, that means we can actually cancel out. Now we can cancel out because this is multiplying everything else. It's not a term anymore. Now we actually have two things, two values, because 2 to the power minus 3 times 2 is some value, right? So it's some value times 2 to the power x. So now we can actually cancel out 2 to the power x and 2 to the power x at the bottom, correct? And so from there, then you only left with 2 to the negative 3 minus 3 times 2 all over 2 minus 2 to the power 2. Okay, but this 2 times 3 times 2 gives us what? It's actually just 6, right? And then we have 2 to the power 1 over 3. So let's separate this. So what I'll do in this case, when you have to create a fraction at the top as a numerator.
We drink the 1 over 3 now.
Yes, it's 1 over. So it's.
We drink it.
So where? Where's 3 there?
We drink the 1 over negative 3.
Oh, this is a 2. Sorry, that's just bad handwriting.
No. No, the 1 over negative 6.
Sorry?
Oh, is that a 2? Oh, it's a 2.
Yeah, that's a 2. Sorry, my bad handwriting. Sorry. So yeah, that's a 2. So it's 2 to the power negative 3 minus 6. And 6 came from 3 times 2, right? And so now, because this fraction, this exponent here is a negative exponent, that means it has to become a fraction, right? And because they said that we mustn't use a calculator. So the best thing you could do for yourself in this case, you can convert 2 to the power negative 3 into a fraction where it would be 2 to the power, it's 1 over 2 to the power 3. Okay, let's try and write that better. Let me try and harden my hand. Minus 6, which is what? The numerator part, divided by the denominator, which would have become 1 over 2 to the power 2. like that, right? And then 1 over 2 to the power 3 would be 1 to the 8, right? Minus 6 divided by 1 to the power, 1 over 4, right? And then from there, 1 minus 6. So if you have to do this, now you just have to do this as, without a calculator. So you'd say 6 times 6 times 8. So you'd say it's 1 minus 6 times 8 all over 8, like that. To make it into a mixed fraction divided by 1 over 4. So what would you get there? So 1 minus 6 times 8 would be what? So 1 minus 6 times 8, that would be minus 47. So it's minus 47. 47 over 8, right? Divided by 1 over 4, right? And then from there, you just use your fraction rules. So it's minus 47 over 8. We can't divide fractions, we multiply them. So we change the denominator into the numerator into the denominator. So it's 4 over 1. But then this, you could have just multiplied it like this and that, and then you could have simplified it further. Or the easiest way, since you have 8 and 4 there, that just means it's 4 over 8, and 4 over 8 would be what? It would be half, right? So then you could just say it is minus 47 over 2. And that would be your solution there, right? Because there's really nothing more you could do, right? Unless you want to write it as a what you call it,
It's more
as a mixed fraction, but this is sufficient. Okay, but I want to also show you something. So for instance, if you're doing exponents and you actually find a numerical value at the end, just to make sure your numerical value is correct, what you could have done is you could have actually substituted x with a particular value. So you could have actually said, I have 2 pi minus 3. And on your calculator, like if you want to check it, you could check it on your calculator and you say it's pi plus 1, like that on your calculator. And it's 2 pi plus 1. Oh, not plus 1, it's minus 2, minus 2, right? And you'd actually get the same value if we are correct. So try it out. Let's see. So if you get a number at the end, a numerical value, then you could also check it by just adding any number or putting any number that you like into the place of x, and you'd see that it should give you minus.
What number must I put in?
Sorry?
What number must I put in?
So you can put in any number that you think of. So for instance, I'm going to say, so I'm also doing it on my calculator. So I'm going to say 2 to the power, I'm going to use pi minus 3 times 2 all to the power pi plus 1. So just to check our value if it is correct, all to the power.
Just 3 times 2, no?
Yes, it's 3 times 2, but then the 2 is raised to x plus 1. So yeah, I get the same value. I get the same value. Let me show you maybe. So you see the value there. So as you can see, so there's equals to here. Let me just check. So there's equals to there. You see what I did? I put it as is, but I only put a value in that place. And then you see the answer. There's minus 47 over 2. So do you see that?
Yeah.
Awesome. Okay, so that's basically.
That, yeah.
Yeah, so that's another way you could just check, especially when you have a value as an answer at the end. Okay, now we do the next question. So the next question is basically solving for x when we have exponents, right? So the first one that we have there is actually 2 minus 16, right? So what's this, 2.2.1? 2.2.2. It's 2.2.1. So 2.2.1, sorry, and that's minus 2 minus 16 x to the power. So it's 2 minus 16 x to the power minus 3 over 2, that's equals to 0. Let's see, let's check here. Yeah, okay, awesome. So we have this one. Now, this one's actually is quite straightforward in a way, because you could get rid of the negative 3 over 2 quite easily. So what we can do in this case, we can just take 2 onto the other side. If we take 2 onto the other side, it becomes minus 2 by minus 16 x to the power negative 3 over 2, right? And then we actually have minus 16, so let's divide by minus 16 on both sides, right? Minus 16 minus 16, so it's minus 2 divided by minus 16, and that would give us 1 over 8, right? 1 over 8. It's 1 over 8. And then we have on the left-hand side, x to the power negative 3 over 2. Now, how could we get rid of this? We could multiply by the opposite, right? And the opposite meaning that we take the denominator and make it into the numerator into the denominator, but we still need to multiply by negative to get rid of the negative, right? So then it is 2 over 3. But whatever we do on the left-hand side, we must do on the right-hand side. Therefore, then it's minus 2 over 3 here as well. And then you can just hit it on your calculator what 1 over 8 all to the power minus 2 over 3 would be. And the solution to that would actually be just 4. Okay, so when x is equals to 4, then this would satisfy the equation. Okay, the next one. So the next one now it's 2.2.2. So with 2.2.2, basically, what do we have here? We have 2.2.2, so 2.2.2, and we have 4x plus 8, that is equals to 9 times 2 to the power x. And in this case, it's actually a quadratic in a way, but it's an exponential quadratic. So what you could do, 4 to the power x, 4, you know, is actually 2 to the power 2. So you could have written this as 2 to the power 2x, right? 2 to the power 2x plus 8. Now you took 9 times 2 to the power x onto the other side. So you'd have it like this. That's all supposed to be equals to 0. And then you'd say it's 2 to the power 2x minus 9, or 2 to the power x plus 8. Now there are two ways that you could have done this. If you if you just not very comfortable with this type of form, the form in which it is in, you could use the K method, or you could just factorize it as is if you are able to see what would be the factor. So if you, for instance, the more, I think most people would get confused with this one, but the more difficult way would be that you just factorize that as is without using the K method. But the idea is that for 2 to the power x, you should just think of it as a variable being just x. The entire thing being 2 to the power x, that's just being a variable. So that means on the other side, you actually have a square variable, because 2 to the power x is the variable, right? So you have a square variable, and the other one you don't have a square variable. So it's still a quadratic. So you would have said it's 2 to the power x like that, 2 to the power x like that. That's supposed to be equals to 0. And then you go to 8 and you'd say, okay, what are the two numbers that I would multiply together to give me 8? But again, this, you could also use the quadratic formula. It's still the same thing, right? But when you use the quadratic formula, if I put it on this side, it would mean that the answer that you're going to get, right? When you take B and B and C and A, it would have been minus 9 plus minus the square root. If you use the quadratic formula, minus 9 squared minus 4, and what's this? That's, I think, what is it? It's A or B. It's 8. Okay, so I'm just gonna put 8 and 1, whichever order it is, doesn't really matter. And then all divided by 2 of 1, and the answer that you would have gotten for either of them, you would have said it's 2 to the power x is equals to, and 2 to the power x. So then the answer here would have been either, so the first one, we would say that it is 1, and the other one would say that it is 8, right? So in this case again, so this also tells us what the roots would be. So what are the two numbers that would multiply together to give us 8? It could be 1 times 8. So 1 times 8, when we add it together, should give us 9. So then we just have to make it is -8 and -1. And then when we say it's 2 to the power x minus 1 is equals to 0, or 2 to the power x minus 8 is equals to 0, you could have just said this is 8 to the power 2x, which, as you can see, this is the same as that. So even if you use the quadratic formula, you just take the 2x and the 2 to the 2x as variables, okay? And then what you actually get, what this quadratic formula is actually equals to, is just 2x, like that, okay? So as you can see, we got 2x is equals to 8, and we got 2x is equals to 8 as well. And in this case, then you have 2x is equals to 1. But now you're not done, because you're trying to solve for x, right? So now what we do is it's 2 to the power x, 2 to the power x is equals to 8. But luckily we do know 8 is actually 2 to the power 3. So it's 2 to the power 3. And it's 2 to the power
And you can
x.
drop your bases, therefore x is equal to 3.
Yes, so x is equals to 3. And on this side, it's 1. But 1, we do know that there is an exponential rule that says for any base that is raised by 0, it's 1. So in this case, we want 2 to be the base. So we just made this base to be 2 to the power 0, which gives us 1. So it's 2 to the power x, and then the bases are the same. And so we drop it, and it's 0. And basically, that's what you get. And it would work the same way here as well, because as you can see, we actually have the same thing at this point and at that point, as you can see there, right? But now with the K method, just to also explain the K method, if it's 2 to the power 2x minus 9 times 2 to the power x plus 8 is equals to 0. And basically, then we would just say we would let 2 to the power x to equals to k, right? Or k is equals to that. And then so wherever 2 to the power x is, we put k. So in this case, remember 2 to the 2x is the same as saying it is 2x all raised by 2, right? Because then it's 2 times x, which is 2x, right? So then that would actually mean that in the place of 2 to the power x for k, then we put in k to the power 2, okay? You understand that part, right? And so this would mean when we do this, this would result in it becoming k to the power 2 minus 9, and then 2 to the power x is k, so it's just k plus 8, and then that's equals to 0, and then you factorize by k, and this would be, I think it was minus 8, and k minus 1, that's equals to 0, and then you'd solve for that, and you'd find that k is equals to 8, or k is equals to 1, but then because you made the substitution where you change 2 to the power x to k, and you want to solve for x, you just bring back the 2 to the power x, so it's 2 to the power x, it's 8, or 2 to the power x is equals to 1, as you can see. And we already did the rest, so we know it's 0 and 3. Right. Awesome. Okay.
Yep.
I think we can, oh yeah, so this is the last question there. So it's 2, 2, 3. It's 2, 2, 3. And then from here, we have, okay, so this one looks interesting. It looks interesting. So it is the square root. It's the x square root. It's the xth root. It's the xth root of 9. That is equals to 243. Now, remember with your surds are actually what? It's actually fractions, right? So whenever you actually had like square root 9, that just meant it was 9 to the power 1 over 2, correct? So in this case, we have the root to be x. So we have 9 to the 1 over x, right? That is equals to 243. 3, right? Now, this looks complicated much, right? It does look complicated, but 243 can be written as 3 to the power 5, right? So it can be written as 3 to the power 5. And 9 as well can be written as 3 to the power 2. But that 2 would become 3 to the power 2 over 3, right? I mean 2 over x. So let me try and open up the space here. Let me try and write it here. So it's 3. So it's 2 to the power x and 3 to the power 5. Right. Now, again, if for instance, maybe you don't know what 243, okay. So if you do, for instance, if you don't know what 243 would be, what you could do is on your calculator, you could say 243, right? Press in 243. And then you say 243, that is equals to, it will give you 243. Press equals to, and then you press shift. And then you look for
Yeah,
the
I know how to do that.
Yeah, so you press shift and then you use function, fact, or I mean, what is it? Is it fact like that,
Fact.
right? Like that.
Mm.
So then you use fact and then you get the answer to be in exponential form. Now, actually, this is quite interesting. Fact is actually what we call, okay, let me not go there. Let me not go there. Let's not go there. But then we have the bases to be the same now, right? Then we can bring down, so it's 2 to the x, that's equals to 5. And then from there, it's just normal solving, right? So you could have taken this and multiplied it there, right? You could have multiplied by x on both sides, right? Like that, by x. And then you would have gotten that it's 5x over 2. And then you divide it by 5, divide by 5. And then that would have been x is equals to 2 over 5, right? Or, I mean, or you could have, at this point when it's 2 to the, it's 2 divided by x equals 5. Now, there's another trick is that you could have just swapped the denominator with the numerator. But if you're going to swap the denominator with the numerator, you should also do this as well, because for all numbers, there is an invisible one underneath, right? But now, if we do that, then it would just be x over 2, that's equals to 1 over 5, where 5 becomes a denominator, and then you just multiply by 2 on both sides to get rid of this 2, and you multiply by 2, and then you get that x would be 2 over
Is that
5.
on the other side? Is that 1 over 5?
Yes, it
I
becomes
mean 2
1.
over 5.
It's 2 over 1. Here, you mean here, or do you mean there?
Yeah.
This is 2 over 5.
The 2 over 1.
Yeah, this is 2 over 1. This is 1 over 5, and this is 2 over 5. Okay, you got it?
Makes sense. Yeah.
Okay, so like we could have just done it like that. Let me just write it again. Over 1, that's equal to. So that would have canceled that, and then you have x. Okay, so those are the two ways that you could have done it. Let's see. Okay, let's see if we still can do maybe like fit in one last one with the exponents. Okay, so yeah. Okay, so this is 3 marks, but it looks complicated much, but it's we'll tackle it as if, yeah. So I think this could be our last one there. Unfortunately, as I said, okay, we'll see. Let's just see how. Yeah, the problem is I have a lot to study, and I won't be sleeping tonight.
Yeah, you don't have to. It's fine.
But yeah. So okay, so it's 2.3. And paper 2 as well, right? It's not yet. We still have time for paper 2.
Yeah, paper 2 is only next week Friday.
Okay, so we'll be able to do as much, way more. Okay, so in this case, then it's 3 marks. We need to simplify fully, right? Now it looks very complicated, I must admit, because it actually says it's square root 2 square minus q square like that times p plus q 5 over 2 all divided by p minus q 1 over 2. Okay, you know what? I want to switch off these lines. So, okay, yeah. Okay, so now having to do this, simplifying, right? And they said p cannot be equals to q. That's that's neither here or there. It's not really that helpful per se.
Yeah.
But how can we tackle this? Now, luckily, inside here, let's start off by factorizing p squared minus q squared. So let's start off by factorizing. Yeah. Now, without the lines, I feel more comfortable to write however I like. So p minus q, like that. We know that this is a difference of two squares. So we have p minus q and p plus q, right? Difference of two squares. That has to multiply p plus q over 5 over 2. But now, or divided by, okay, so what we want to do in this case, we want to try and get the exponent for each, right? And we'd use the third rule. Remember the third rule that says if we have, for instance, the cube root of a and b, that could be written as a of 1 over 3 and b of 1 over 3. Or you could have written it as the cube root of a times the cube root of b, correct? So now we have these two values there. So we have those two values there. So then now we could say the p minus q would be 1 over 2, right? And the p plus q could be 1 over 2. That is being multiplied by p plus q, which is 5 over 6. I mean 5 over 2, not 6, but 5 over 2. And so that's all divided by q minus p, p minus q of 1 over 2. Now, luckily, we can see something that we can cancel out. Q minus p minus q, also to the power 1 over 2, is the same as the one underneath. So this can cancel that over there, right? So since that's canceled, we only left with p plus q 1 over 2 times, right? P plus q and 5 over 2. Now in this case, it's quite simple because p plus q and p plus q are the same, right? That means that we have the same bases. And if we have the same bases, then we just need to add the exponents. So if you have to add the exponents, then we'll just say p plus q. And that would be half plus 5 over 2. Correct? And then we'd have p plus q, which is 6 over 2. But 6 over 2 would give us what? 3, right? 6 over 2, 6 divided by 2 is just 3.
Yeah.
And therefore, that would be our solution there. So yeah, basically that's it. It's unfortunate that we really don't have too much time, but I hope this was helpful as further as possible. And yeah, but other than that, with paper 2.
What time will you finish writing tomorrow?
Sorry?
What time will you finish writing tomorrow?
So I'm writing from past 12. So I think I'll finish around, what time? Around 3 or 4. So around 3 or 4.
Yeah, okay. Tomorrow we do 2 hours.
Yeah, we can do 2 hours, 3 hours, how many hours we could do. Even if, maybe if you're not going to school, you could even do 1 hour in the morning, 1 hour in the day.
I am going to school.
Yeah, but I'm saying for those for paper 2s, right? Whenever you're at home, maybe if you want to go in the morning for 1 hour and then we do 1 hour, midday we do 1 hour,
yeah, we can do that.
Afternoon 1 hour. I'm perfectly fine with that. Okay.
Yeah, that's fine.
Okay, so we can also do it that way and so on, right? Other than that, thank you, and I'll see you tomorrow. Okay, and you text me. Don't forget to text me and about the time and so on. But yeah, and all the best with tomorrow. Please try your best.
Good luck for tomorrow.
Yeah, you too. All the best. See you tomorrow. Okay.
All the thanks.
Okay.
Yeah, bye.
Bye.